I'm an engineer and kind of self-proclaimed evangelist for Raspberry Pi. It's a funny job title, but basically it means that part of my job, as well as being an engineer, I was the first employee of Raspberry Pi, is to go around and sort of share some of the mission behind the Raspberry Pi. The Raspberry Pi Foundation is a not-for-profit educational charity. We were set up not to sell lots of computers, but to promote computer science and to really get people engaged and to get people to learn a little bit more about computers on a more basic level. And so we're very passionate about this. Although I'm the first employee, unlike most startups, I have no equity. There's no one's getting rich out of this. We're doing it because it's a good thing to do. It's run as a charity, and all the profits go back into the charity for outreach and for educational purposes. And so, yeah, we're very passionate about computer science, we're passionate about communicating the need for it, and so my sort of evangelist job title comes to the fact that I spend some of my time sort of travelling around the world and talking to people about this. So who here has a Raspberry Pi or has used one before? Okay, that's pretty promising. There's a lot of people in the audience. So what I think we're going to do is I'm going to talk a little bit about the history of the Pi. You might know this, but if not, I'll kind of fill in. Then afterwards, what we'll do is we'll have a short demonstration from Josh about one of the really cool implementations of the Pi you can see in front of you. Then after that, if anyone else has any Raspberry Pi projects they've brought along, you can kind of have a few minutes to talk about that if you want to. I noticed there's some interesting things in cardboard boxes down there. And then we'll leave lots of time for Q&A. I'm very aware that in the age of YouTube recorded talks, the real value of coming places is to talk to people and to answer questions. You can watch hours of me speaking on the subject on YouTube, but this is really the chance to actually engage, particularly with Josh and I here together, which I think it makes for hopefully some interesting discussion as someone who's propagating doing these kind of designs and someone who's actually had to go and build it. So that'll be great. So the Raspberry Pi Foundation is based in Cambridge in the UK. And it's really born out of the computer science laboratory for the space there. We were founded by a number of Cambridge academics, primarily by Eben Upton. And what happened is, Eben was in charge of admissions for undergraduates' studies of computer science at St. John's College in Cambridge. And while he was there, he and the other academics noticed that they were getting kind of fewer and fewer people applying to study computer science each year, and there was a significant decline in the number of applications, even to somewhere like Cambridge, sort of since the 80s. And even worse than this, not only were they having fewer people apply, but actually the skills they were coming in with were getting lower and lower. So whereas in the 80s they were coming through with a couple of basic programming languages, maybe a bit of assembler, and kind of some understanding of how the hardware of a computer might work, they were then getting kids coming through who kind of had written a website in Ruby and were pretty sure that was computer science. And this is really worrying, because the problem is it means that if they have less skills coming in, they have to start at a lower point. It means they have less skills coming out. And not only do we have people with lower skills, but we have fewer of them. That's really bad for the industry, it's bad for the economy, and it's really bad for us as geeks because we have less cool toys to play with. So they went away to try and figure out why it was, why we were kind of losing these skills and why people just weren't as excited by computer science anymore. And what they realised is, primarily this was driven by the kind of computing devices that we grew up with. So if you think back to kind of the 80s where people had Spectrums and Ataris and things, they were devices that you had for play. Sure, some people use them for business purposes, but you weren't reliant on them the way we are computers today. If you think about it, we're reliant on our laptops for communication, for work, for our banking, for everyday tasks. It's an essential part of life. But back when you had those Spectrums, it was something that you hooked up to the TV and you kind of played with, you experimented. It was something new and novel to go and learn from. And also if you contrast sort of playing games, we have a situation today where you have maybe an Xbox 360 or something. Your Xbox 360 has greater processing power in terms of floating point operations per second than a 1990s Cray supercomputer. The problem is, it's actually, instead of being a general purpose device like the Ataris or the Spectrums were, this is entirely enclosed, it's hidden. Microsoft and Sony don't want you to know anything about the silicon, anything about the processing capabilities. you take the PS3, cell broadband engines are really interesting and awesome bit of silicon, and yet, it's designed purely in order to, further their business model of selling you games. And, they kind of almost don't want you to know anything about it, other than the fact that, there are slightly more pixels on your characters in your favorite AAA titles. And, you even get to the situation where you have guys like GeoHot who go and hack the PS3 to run Linux, so you can really use this, use the awesome silicon that's available, and they get sued by Sony Corp because it's breaking their business model. You contrast that with back in the 80s. If you wanted to go and play a video game, you'd go to the newsagents, you'd buy a magazine, you'd flick through to find a game that looked fun, you'd then type in the code, run it, and then go and play it. And so not only did you have some understanding where this was coming from, but you could modify it, you could play it, and actually the whole process was a lot more understandable, as opposed to today where, computer systems are getting more and more sort of, hidden and obfuscated. The other kind of computing device we're seeing becoming quite ubiquitous today is sort of tablets and smartphones. These are very advanced bits of kit. I had an opportunity to go speak at the Apple campus at Cupertino, and what they were saying was, with the iPad, it's about delivering digital content. It's about you and the digital content. It's not about the computer. What they want to do is make it so intuitive and so invisible that you're almost not aware of the device you're using. You're not aware of the specs. You look at the modeling, the marketing for the iPad. And it's now kind of moving to a situation where it's the new iPad. They don't even want you to know what's inside it. It's about a method to deliver content. Now, don't get me wrong, it's phenomenally good if what you want to do is deliver, academic information for an arts class or something. But if what you're trying to do is inspire kids to play with computers, and the things they've been using are hidden from them, so that they're not even aware of what these computers can do, or even really aware of what the computers they're using are, then no wonder it's difficult for them to become inspired. And so, we went away and they thought about this, and they realised that what we really needed was, maybe an additional device that was a toy, that was something to play with. They weren't going to be able to compete with your desktop, they weren't going to be able to compete with your games console, but maybe they could produce an additional computing device that, you weren't dependent on for your online banking. It was something where, if you could really experiment freely because it wasn't something that cost a lot of money or that you were dependent on. The important thing for this was they realised if they were going to get parents to buy their kids an additional computing device, then it had to be cheap. It had to be so cheap that people could almost impulse buy, and that there wouldn't be any hesitation from parents or schools that maybe didn't even see the value of computing or computer science, and so that they could buy it without really having to think about it. And so they somewhat naively took $25 to be the price of a textbook. Turns out that wasn't very accurate, but they kind of misremembered that. They set that as the price point that they wanted to go and produce this computer for. And they spent a long time trying to come up with a solution to do this, and they really struggled. They just couldn't find a way to make it cheap enough. So Eben left academia. He then went to go work at Broadcom, where he was working on processor chips that go on smartphones, applications processors. And I actually got to be an intern for him at the time. And it was interesting because Eben kind of had this brainwave. We had this development platform, so it's a very large, expensive PCB that allows phone manufacturers and software engineers to talk to the processor and to make sort of practice platforms. And they realized that actually because of the scale that smartphones were running at, the components on this board were very cheap. And actually, it was feasible to cut this thing down to make a standalone computer that would be at this $25 price point. A lot of people sort of ask how we ended up with the Broadcom processor. Raspberry Pi wasn't a situation where we set this up as a startup and came up with a clean room design. Raspberry Pi was born out of the fact that Eben and the academics had this desire for this computer, and actually most of the engineers working at Broadcom, and Eben sort of mentioned this desire to make this cheap computer, and we all kind of wanted one. That was the initial motivation, is, hey, we can make a cheap computer, that sounds cool, I can think of a million uses for that, let's go and do it. And so, this chip, which had initially been a graphics coprocessor, ended up becoming the processor which was on the Raspberry Pi. So it's, being a bit technical, but what's quite interesting is the processors on this, the Broadcom processor, is 98% by die area a GPU. So only 2% of the die area is used up by the ARM core. It's a very small amount of silicon. And that's as a result of the fact that, if you think back to kind of your Apple Is, you had many, many bits of silicon on your computer, and that was almost, chips were at the gate level. Those have become shrunk to the fact where you have more and more gates on the same chip and more functionality on the same chip. In sort of recent history, your smartphone would have a baseband processor, you'd have a applications processor, and then you also have a graphics coprocessor. Much in the same way as you might have a video card in your desktop. We've now reached this point where the technology shrunk so much that actually they can put effectively the processor and the video card on the same chip. Have these things called system on chips or SoCs, and that's what this is. And so, we had this graphics coprocessor, we had a bit of space left on it. Eben said, hey, it'd be kind of cool if we could put an ARM on there and make this a general purpose computer. And so they kind of worked on a bit of a skunkworks basis in evenings and weekends to put this small ARM core on it. We didn't have a very large ARM core because there wasn't an awful lot of space left. We had the largest ARM core we could fit on that empty 2% of die. And that's where the chip came from. And that's how we ended up with this platform. As I say, it wasn't a clean room design. It was a situation where we realized there was a board where we could get hold of a chip that was sub $10, what we could port Linux to, and that actually we could cut that down to be this cheap, open, additional computing device that we saw this need for. And so, Evan kind of took the schematics and a red Sharpie and went through every single component we could possibly get rid of, cut it down to be a BOM, which we could produce for $25, and the Raspberry Pi was born. One of the great things about computer science, I always say, is that you get good internships. You go do law or journalism, and you might end up kind of following someone around and maybe doing some photocopy and making some coffee. If you go and do computer science, you might end up doing a significant amount of work to producing a computer which sells millions of units. When Eben went to the Broadcom management and said, we really want to do this, they said, yeah, sure, you can do this, but you can't spend any money on it. You can't spend any engineers' time. Luckily, being an intern means I'm a zero-cost resource, and so I got to do some of the original kernel porting and some other cool stuff, which was it was really awesome. And at that point, we didn't think we'd make that many sales. We thought it was something that maybe a couple of geeks would like, something we could maybe get into some education venues. We thought maybe 10,000 a year in education in the UK. That was the kind of ballpark we're aiming for. We then went to do an interview with the BBC. It's actually quite funny because I'd taken some photographs because I'd helped Evan do some of the initial kernel porting. And I'd actually gone back to university at that point. And I'd taken some photographs and emailed them to him. And I remember going on the BBC website and seeing those photographs I'd taken from my smartphone on the BBC. And there was a news article with Eben, and suddenly the world knew that we were going to produce a computer for $25. And it turns out a lot more than 10,000 people wanted to buy a $25 computer. To the point where we had to put up a kind of a register your interest page, and we had 100,000 people express pre-orders. That's before we'd even manufactured any. Actually, in the week of launch, when we launched, our partners who were distributing them, Farnell, a group of companies, and Allied, who trade as RS back in the UK, their websites crashed under demand because so many people had logged on to try and buy them. I see some people might have been caught out by that. In fact, at our week of launch, despite the fact she had an album out at that point, Raspberry Pi was trending higher on Google searches than Lady Gaga, which was kind of unexpected, right? The story I always tell is there might be some people in here who agree with me that sometimes you feel a bit undervalued as a computer scientist, particularly if you're working on bits of silicon or bits of software which are going to go into hundreds of millions of people's phones, but they kind of never really realise that work's being done. And I think sometimes it is a bit overlooked. And I certainly kind of felt like that as an intern. It felt like we were working very long days because we were spending our day jobs at Broadcom and our evenings working on this as well, and weekends too. And one of the things we did is we ported Quake 3 to the Raspberry Pi, which is kind of cool. It runs at sort of 60 frames per second on a $25 bit of hardware with no active cooling, which is pretty cool. We did that work to port it, and we thought it was a kind of cool thing. And Evan said, "Oh, we should do a YouTube video and put it online. So we did the YouTube video, and